something that you have learned before. Okay, but I hope that you can get something new lah from my lessons today. Alright. You ready, class?
Yes.
Alright. So before that, I hope that you already watched the video. Dah tengok ke semua video tu?
Dah.
Okay, good. Okay, sebab kalau awak dah tengok, saya lega sikit lah. Maksudnya you have some idea. Okay, ataupun an idea pun jadilah. Okay, on this chapter. Alright, so for the outline for today's lecture, we're going to see forces, first Newton law, second Newton law, Newton's third law. Application semua kita tengok tomorrow. Sebabnya today I think we sempat we only have time to see all these 4 point dulu. Tak apalah. Okay, no rush, right? Okay, so basic of forces and free body diagram. Okay, so we'll see this. Okay, so we have several forces, okay, acting on a body in different situations. Alright, so that force kita akan kejap tak keluar. Kita akan transfer pada free body diagram so that mudahlah untuk kita solve dia. Okay. So biasanya for case application, okay, kita akan try to determine weight, static friction, kinetic friction. But all of this problem, okay, so kita akan, we're going to use free body diagram. Sekejap siapa masuk? Sekejap. Oh, ada yang kena ask to join juga Kenapa tak dapat invitation saya Alright, so forces is defined as something capable of changing state of motion or size or dimension of a body. State of motion. Maksudnya dari perlahan kepada laju, size kepada ni. If not, then maksudnya that force tu ada tapi mungkin dia is not an effective forces. Macam tu lah. Okay, gravitational force. Contoh kita ada gravitational forces. Okay, and then is the forces involve attraction between massive body. Okay, it's a long range forces, the weakest forces in nature lah. Macam tak rasa, tapi kita perasan benda tu. Kita perasan apa? Daripada kesan. Okay, so kita tak nampak. Force memang kita tak nampak ya. Right, so and then we have also, kalau yang kuat sikit, kita ada electromagnetic force. Electromagnetic forces ni lah yang kita guna untuk handphone kan. Handphone, apa lagi? Radio, semuanya daripada electromagnetic force ni lah. Wave. Tapi dia electromagnetic, dia boleh jadi force jugalah. Okay. So daripada wave tu lah. Okay. Attractive and repulsive forces between electric charges. And then strong nuclear force. Okay. Force yang dia dari nuklear tu je. Okay. So strong nuclear force dia. Attractive forces bonding neutron and proton in atomic nucleus. Okay. So dalam satu atom Okay, so dia ada nucleus kat tengah dia kan, nucleus kan. So around dia ada proton, neutron, macam tu. So apa yang panggil apa? So proton and neutron tu dia ada satu attractive forces. Okay, yang attract untuk dia ada dekat situ. Okay. Sebabnya elektron akan equivalent dengan number of proton. Tapi macam mana proton boleh ada sekumpul kat situ? So that is the attractive forces. So of course that force sangat kuat. Why? Why? Because kan kita belajar kalau positif dia akan repel. Tapi dia boleh terkumpul. Maksudnya that force sangat very high. That's why the effect tu boleh jadi bom atom nuklear tu. Macam tu. Okay, the reactivity tu. Dia adalah strongest forces in nature. Nampak je macam dia adalah dalam satu atom ada that force yang ni. Tapi dia sangat-sangat kuat. Sebab apa? Dia between positive and positive. Tapi positif kan kita kata repel kan. Tapi positif tu bersatu. Sekumpul kat tengah-tengah. Macam tu. Okay, dan sampai satu tahap dia boleh jadi aktif lah. That's why kat situlah terjadinya bom nuklear ke apa yang patut tu lah. Alright, and then weak nuclear forces ni unstable condition for atomic nucleus. Okay, so macam dia dah proton number yang besar. Okay, so proton number yang besar, so dia dah makin weak. Then dia akan berlaku decay untuk menstablekan diri dia. So dia akan lepaskanlah beberapa proton ke macam tu lah ataupun elektron. Alright, so basically okay, the SI unit for force is kilogram meter per second squared. Okay, or Newton pun boleh juga ya. Okay, mass. So because most of the case that ataupun most of the problem that we're going to solve, okay, in that related with law of motion is akan about the body. So a body is tu dia akan ada mass. So how we define the mass? Mass is a measure of a body's inertia. Boleh kata macam tu lah. Ketahanan badan. Bukan ketahanan badan. Inertia tu. Okay, tengok nanti. So, scalar quantity, kilogram, independent of location. So, mass dia independent of location. So, kalau dekat sini, mass awak banyak ni. Okay, and then nanti awak pergi bulan, your mass akan sama juga banyak tu. Okay, yang different adalah apa? Your weight. Okay. If the mass of body increase, then its inertia will increase. So orang yang berat, contoh macam orang yang berat dengan orang yang ringan ataupun orang yang besar sikit badan dia dengan orang yang bigger and smaller kan. So bila kita tolak, mana yang akan tumbang dulu? Macam tu lah. Okay, so dia akan proportional. So higher mass, inertia dia pun akan tinggi lah. Maksudnya how is pula inertia dah define belum tadi tak ada inertia, tak define lagi ke? Belum lagi. Sekejap lagi kita define inertia pula. Okay, and then weight, the force exerted on a body under gravitational field. Okay, so gravitational field, so weight ni different lah. I mean dia akan depends pada tempat lah. Because the value of G varies at different localities on the Earth's surface. Cuma mungkin the different tu tak terlalu besar. Okay. Dan kita kata weight ni pun adalah, maksudnya contribution dia very small lah. So it always directed toward the center. Okay, so how we draw weight? Okay, how we draw weight? Okay, so macam mana kita akan lukis direction untuk weight? Dia akan directed toward the center of the earth. So contoh straight sebenarnya. So this body, so towards center, so ke bawah, itulah weight dia. Kalau dia sengit macam ni, ini surface, ini object. So kat mana dia? Dia akan ke bawah sini. That is the W. Okay. Katalah dia dekat atas, surface kat atas. And then, naik roller coaster kan. So awak kat atas, then this is your W. So akan always pointing toward the, so that is how we draw the weight tu. Okay. Lama. Okay. Alright. So the equation is equal to mg. M ni apa tadi? M is our mass tadi yang kita define sebagai a measurement of inertia. Times dengan G. G is yang biasa kita guna 9.81 lah. Boleh check lah 9.8 ke 9.81. Alright. Next we go to tension. Tension is one of the force juga. Okay, the force in the string that supports the weight of the body is known as tension. Tension in an object results in pulling force on its ends, such as in a rope tight. Okay, cuma tension akan ada dalam dua arah. Dalam satu on a rope ni. Okay, in a rope. Okay, it have two direction, but when we refer to this body, then how you draw the tension akan away from the body, faham tak? That is how we draw the direction for the tension. Okay, on a string. Contoh kalau macam ni pula. So ni tension dia mana? Tension dia ini. Okay, arah ke sini. Kalau refer body ni, tension dia arah ke sini. Itulah maksud saya. Tapi sama tak value dia? Dia value kalau dalam satu benang, kalau dalam satu in a rope, that value akan sama. Okay, even dia terpisah dengan puli pun, tapi dia masih satu tali ni connected, okay, but still connected, then this rope only have a tension sahaja, walaupun ada dua objek yang berbeza kat sini hang kat dia. So cuma ada satu tension, but apa yang different? Again, different pada dia punya direction, ya. That's how we draw the diagram untuk tension. And then we have static friction. We have frictional force ya. Frictional force macam mana frictional force ni exist? How this can we consider? Why we consider? For case yang macam mana kita akan consider frictional force ni? Okay, kita akan tengok. Alright, kita ada static before it's move. Okay, when it move, kinetic. Okay, tapi kadang kalau static ni, okay, memanglah dia kata before it's move kan. Tapi kadang yang moving yang without acceleration. Acceleration maksudnya apa? Dia bergerak dengan velocity constant. Kadang dia masuk dalam static friction. So depends lah pada soalan tu. Kadang dia dah consider sebagai kinetic friction even it move with velocity constant. Depends. Tapi sepatutnya kalau dia moving, sepatutnya kita consider sebagai kinetic frictional force. And then rolling ni tak adalah. Yang ni tak payah ambil tahu lah. Kita cuma ada static ataupun kinetic saja. Dan sepatutnya kinetic punya friction kena kecil lah daripada static. Barulah dia boleh bergerak lawan force tu kan. Okay, so sepatutnya that value akan smaller. Maybe compared to static. Alright, so direction of the frictional force exerted by a surface akan always opposite direction of the motion. Frictional force, frictional and the reaction forces are always perpendicular. Okay, so let's see this diagram. Okay, so this is your force. So logiknya dia akan bergerak arah sini. Betul. Tapi ini force lah. Tapi dia kata block at rest. Bila at rest, dia akan ada apa? Ada frictional force opposite direction to the motion. Sebab dia force arah sini kan. So opposite direction to the motion. Alright, even dia tak move pun. Tapi dia dah bagi force kat situ. So before it starts to move lah. Okay. Sekejap Sekejap. Okay. So this is how we draw the frictional force opposite direction. Then another one condition is perpendicular. Perpendicular to the normal force. Okay. So block at rest, static friction, block about to slide. Okay, dia akan ada static friction yang maksimum. Okay, so static friction ni pun boleh berubah dia punya value lah. Depends pada surface. Okay. And then block is sliding. So bila sliding, then dia akan ada kinetic friction. So inilah you need to careful. This is how we draw. Okay, for case yang macam ni tak ada masalah. Cuma biasa for case yang tangga. Kita letak kat dinding. So macam mana ni? So kita kena you need to imagine. Ya Allah. So you need to imagine lah. Just in case if the ladder fall down. So where is the direction? Yang atas ni kan dia lie kat sini. Ada sentuhan kan? Because of the sentuhan lah that ada apa? Contact kan? Contact. Because of that contact lah that cause this tangga stay macam tu. Faham tak? Okay, I mean tangga tu boleh lie on this dinding. Okay, so because of that contact. So means that dia dibantu oleh friction. So mesti ada friction kat sini, which is static friction lah. Dia menyebabkan kita tak ada gerak. So kalau kita tak ada gerak, static friction tu kena tinggi lah macam tu. So which direction? So which direction tu, okay, kita kena assume kalau possible untuk tangga ni jatuh, dia akan jatuh arah mana? So yang ni dia akan arah ke bawah. And then dia akan arah ke sini kan? Okay. So maksudnya dia akan opposite direction. So your Fs akan in this direction. And at here your frictional force akan in this direction. Okay, macam tu lah. Alright, dia kata always perpendicular ni. Okay. Boleh ya kelas? Okay, force that resists. Okay, frictional force. Okay, so apa frictional force ni? Sebenarnya kita perlukan frictional force ni ya. Memanglah dia macam is kind of resist the motion. Okay, of one surface relative to another. Okay, it is in contact. Okay, cuma okay, kejap kelas. Ada hai. Kejap. Allah. Okay, sorry ya kelas. Aduh, banyak pula interruption. Okay, sorry. Mana tadi ya? Alright class, sorry ya. Okay, so let's continue. Okay, frictional force is dia boleh jadi berguna, okay, ataupun sometimes we don't need the friction. Okay, sometimes we don't need the friction. Okay, so contoh case yang we don't need the friction. Biasa kita nak tayar kereta. Okay, tayar kereta. Tayar kereta kita nak ada bunga kan. So that we increase the frictional force. Okay, so that bila kita tekan brake tu, then dia tak meluncur lah. Tapi untuk racing car, tengok tak macam mana tayar dia. Dia tak ada bunga langsung. Supaya dia nak yang memang smooth. Yang tak ada, maksudnya nanti kalau racing dengan ada bunga kereta banyak, habislah minyak kan. Dia berat. Okay, so dia nak yang smooth. Dia nak kurangkan frictional force tu. So depends pada dia punya application frictional force tu. Sometimes kita perlukan dia tinggi. Contoh yang bunga tayar backhoe nama dia. Okay, yang truck tu kan tebal sangat kan. Okay, so that one sebab dia sangat berat. So kalau bila dia berat, so nanti kalau apa panggil tu, kalau kontak tu tak kuat dia tak kuat dengan jalan, then nanti dia mudah meluncur pula. Macam tu lah. So frictional force ni depends pada dia punya application. Okay, so the motion of one surface relative to another which it is in contact, dengan syarat frictional force semua berfungsi if and only if it is in contact. Okay, then kalau tak ada contact, tak ada. Okay, why? Sebab tadi perasan tak F kita equal to mu n. So dia akan proportional dengan apa? So dia akan proportional dengan your normal force. Kalau kata, okay, for case yang dia hanging, okay, for case yang hanging, okay, so it have no normal force. So tak ada normal force, frictional force pun tak ada lah. Okay, so dia akan proportional these two. Okay, so higher the normal force, higher the frictional force. Baru keluar rupanya. Baru keluar, okay. Ya, so inilah yang saya nak cakap tadi. So for frictional force akan proportional. So what is your coefficient of friction? So it can be defined as your frictional force, your ratio of friction between frictional force to reaction force is dimensionless and depends on the nature of the surfaces. Okay, and then free body diagram. Nantilah. Kejap lah ibu kelas. Nantilah. Nantilah dik. Sekejap ya. Banyak pula kacau ni. Okay. So the free body diagram of a body shows the body alone with all the external forces on it. Okay. So free body diagram of a body. So this is how, okay, so all the forces tadi bila act on a body. Okay, so to make it easy, okay, kita akan transfer pada satu benda yang we call it as free body diagram. Okay, bila kata free body diagram, it's supposed to only have all the forces act on that body without the body. Contoh macam kalau awak nak cakap pasal force act on this body, box kan, okay. But when transferred to free body diagram, suppose it's only come out from a point to this, to here, to here. Okay, so this is the correct and perfect free body diagram. Together with tampak ni resultant forces atau kena direction then determine. Okay, body alone, all external forces. Okay, and then kalau nak lagi determine, yang ni adalah apa? Panggil apa? Akan represent the magnitude of the force, and this represent the direction. So direction ni wajib lah. Cuma kadang kalau value of force tu tak adalah kita sampai measure kan. Kalau 20 tak adalah kita tulis ukur 20 cm. Because we only sketch je lah. Alright. Alright. So let's see an example. Okay, for you to get familiar with the free body diagram. Okay, because for this case, from this case, we can have two free body diagram. Okay, you need to know how to draw two free body diagram. Okay, so a traffic light weighing Newton hangs from a vertical cable tied to two other cables that are fastened to a support. Okay, so the upper cables make angles of 37 here. So dah ada gambar, senang lah. Okay, so dah ada gambar, mudah sikit. So kita dah tahulah T1, T2, T3. Find tension in each of the three cables. Okay, cuma yang hang dekat betul-betul dekat objek is your T3 saja. Okay, okay. Tapi this T3, okay, affect your another two rope ni. Rope ke kabel? Okay, kabel. Another two cable. Okay, so you need to draw two free body diagram. Okay, so satu kita ambil this as the object. Another one kita ambil point yang the bagi apa, point titik equilibrium dia. Okay. Alright. So for the object, it have weight in this direction, FG. Kalau ikut buku ni dia akan label sebagai FG. So FG is your weight lah. And then T3 akan upward macam tu. Macam saya cakap, how to draw this, how to draw the tension. Tension akan always away from your point yang awak nak cari tu. So T3 away. Okay, this is your first free body diagram. Your second one, now your T3 arah bawah pula. Sebab apa? Sebab yang kita refer, point yang kita refer adalah above dia. So dia akan away. Yeah, this is how we draw the tension. And then T2 also kita akan ambil away. T1 pun kita ambil away macam tu. Okay. Then how to solve this? Okay, so how to solve this? Kita akan pergi one by one. Tapi nanti saya akan tunjuk lagi lah yang lebih lanjut. Cuma yang ni kita buat je lah macam ikut yang dia ni. Dia cakap ni. Alright, so from the first free body diagram, we get this equation. Since, okay, the question asks you to find T1, T2, and T3, there are means there are three unknown. When we have three unknown, you need to have three equation to solve these three unknown. Okay, so three equations. So first one may get from the first free body diagram, which is T3 equal to your FG. So settle masalah untuk T3. Dah dapat. For T1 and T2, okay, T1 and T2, okay, kita buat macam table untuk vektor kita. So T1, what you need to do is you need to resolve. So you resolve lah. Okay, so you resolve. Okay, so since your T1 is in this direction, this is the angle. So here your component X akan negatif lah sebab to the left. Alright. And then T1 no problem going up. So dia akan dapat positif. So T1 sin 37 no problem. T2, your T2 is in this direction, then no problem juga. Both will have positive, then just list down here. And let's put it in equation. So when we write it in equation, so we get this equation fx, fy. So dah ada dua equation where we can solve the other two unknown, T1 and T2. So from sini, dari sini, from here, so you can simply use your punya algebraic punya ni lah. So solve this and you may get your T1, your T2 and your T3. Okay. That one is okay, so dah exercise. Cukup dah. Baru 4:30. Alright. Oh, patutlah tak masuk Newton law lagi. Alright. So now we're going to see Newton's first law. Okay. So Newton's first law, Newton's second law, Newton's third law. So Newton's first law of motion, okay, states an object at rest will remain at rest or continues to move with uniform velocity in a straight line unless it is acted upon by external forces. Okay. Alright. So kesimpulannya adalah sekejap. Sekejap. Okay. Mencabar ya. Right. Okay. Law of motion. Okay. So means that, alright, the net force, your net force, okay, will equal to 0. Okay, sebab dia kata remain rest ataupun uniform velocity. Uniform velocity MA. A acceleration sama dengan kosong. At rest A sama dengan kosong juga. So these two condition V sama. Okay, these two condition yang akan menyebabkan first Newton law ni applied. Okay. So the net force here doesn't mean that contoh macam awak kata buku atas meja. Lepas tu soalan pun tanya, what's force act on this book? Awak pun jawab no force sebab equal to 0. But the fact is net force that equal to 0. Ada tak force yang act on dia? We have force act on this object. But because of contoh kita ada normal here, we have weight here. And then contoh we only have these two force. Okay, we only have these two force. Okay, contoh Alright. Then net force N minus W equal to 0. So N sama dengan 0. W. Okay, so means that the value of force is the same but in opposite direction. Then the net force is equal to 0. Macam tu. So maksud that akan menyebabkan that object at rest, remain at rest. Okay, again net force net force. So the first law gives the idea of inertia. Okay, is which ni kita define lah inertia ni. Tadi kita jumpa mass, maksud mass tu adalah measure of inertia. So apa inertia tu? The inertia is defined as the tendency of an object to resist any change in its state of rest or motion. Okay, tendency of object to resist any change in its state or rest or motion. Maksudnya kita tolak pun dia berdiri kat situ juga. Tolak lagi berdiri kat situ juga. Tapi macam kucing ni bukan initial lah ni. Yang ni sebab kucing ni pemalas lah. Ataupun contoh coin. And then kita pull out the cardboard. So bila kita pull out, why the coin not follow the cardboard? Okay, so because of the initial lah. So dia akan stay kat situ. Dan bila dia dah tak ada yang halang dia, then dia akan fall down macam tu. Alright, then we go to Newton's second law. Alright, so Newton's second law, the rate of change of linear momentum of a moving body is proportional to the resultant force and is in the same direction as the force acting on it. Okay, so kat mana rate of change of linear momentum ni? It can be represented by yang ni. Kalau kita nak tulis dalam bentuk kalkulus dia. Change in linear momentum, change in time interval. Okay. Alright. So here dp per dt ni is your change of maksudnya this one we take from the betul-betul pure daripada dia punya panggil definition lah. So we get this ya. Sebelum kita derive jadi equation yang kita biasa guna tu ya. Alright, so kita ambil yang pure dulu. Okay, kita akan derive. Alright. So bila dmv, so kita is actually is in mathematics ataupun calculusnya kita akan write dia in term of this. Apa maksud dia? Maksudnya adalah change of mass dengan masa pun akan we contribute to the a value of force, okay, ataupun change of velocity. Either one lah. Tu maksud dia. Dia kata object at rest or in motion with constant velocity. Just in case velocity tu constant tapi changing mass. Contoh macam rocket. Macam tu. So mass changing. Okay. So maksudnya dia akan ada net force. Okay. Case yang kedua. Object at rest with constant velocity and constant mass. So yang ni semua kosong lah. Which is dia akan jadi macam first Newton law. Okay, so yang ni first Newton law lah. Bila momentum kita constant. For third case, okay. A mass static pula. Okay, the change equal to 0. Okay, and then we only have change pada velocity. So means that it have an acceleration. Then we're going to take net force equal to mass time acceleration, which is the net force is the resultant force, effective force, lagi apa? The net force, okay. So mass of an object into the direction of the resultant force always in the same direction of the motion or acceleration. Sebab apa? Sebab M ni dah scalar. So your force akan ikut apa saja arah acceleration tu. Okay, then from there kita restate balik lah. Okay. Okay. Restate balik that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Macam mana tu? Macam ni lah. Okay, so bila kita dah buat yang tadi, kita ambil yang case paling last tu lah sebagai kita punya fokus. So kita restate balik kita punya Newton's second law, we get this statement. So the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Okay. So 1 Newton. Dulu pernah juga keluar soalan 1 Newton ni. Apa maksud 1 Newton? 1 Newton is equal to is the amount of net force that gives an acceleration of 1 meter per second squared to a body with a mass of 1 kilogram. Mana dapat benda ni? Daripada dia punya unit ini je. Okey, tak ada apa yang magic lah kat sini. The net force. So again, net force ya. So second law ataupun we can simplify your Newton's second law now is your net force equal to your m times the acceleration. So again, F is vector. Manakah? F vector. A also vector. Okay. Cause the motion of an object. If the forces act on an object and the object moving at uniform acceleration, not rest or not in the equilibrium. Okay, so for case equilibrium, kita akan refer back to Newton's first law. For case yang ada acceleration, kita akan equatekan dengan equal to ma, which dia akan jadi under case Newton's second law. Then what the difference dengan Newton's third law? Newton's third law akan consider the reaction force. Okay, where the reaction force is same in magnitude but different in opposite direction. But you need to remember that we are going to consider only the panggil apa? Only the external force. Sebabnya one of these consider as the internal force. Contoh macam ni, wall to hand. Tapi that's the possible. Possible je. Maksudnya possible je untuk kita tanya soalan apa force yang menekan B. Apa force dari wall kepada hand, apa dia. It's still possible. Okay, it's still possible but your answer akan sama in magnitude but different in direction saja. So, bila kita nak tulis dia bagi sama juga, tambah je lah negatif kat sini kan. Okay, so biasanya ini adalah untuk case yang Coulomb force. Coulomb force. So, that Coulomb force is action, reaction, pair. So, force ini kan. Yang K, Q1, Q2 over R squared. So force yang ni pun K, Q1, Q2 over R squared juga. Tapi arah sini. Yang ni arah sini force dia. Macam tu. Okay. Action, reaction. Alright, so contoh we have this case. Kau pada ni. Okay, sikit lagi. When a book is placed on the table, forced by the book on the table, forced by the table on the book. Macam ni lah, macam tadi dia tekan dinding. Contoh yang ni. Okay, so persoalannya, adakah new normal force? Okay, adakah normal force is your reaction to your W? Okay, so adakah dia ni? The answer is not. Why? Because untuk case yang ni mungkin kita nampak dia sama. Okay, for case yang ni, plane macam ni. But for case inclined plane, your N no longer totally equal to weight. Okay, sebab kalau kita declare normal force is your reaction to your weight, that value akan always the same. Okay, but unfortunately, okay, the value, some of the cases, okay, the value of normal is not the same with your weight. That's why normal and weight is not reaction and action pairs. Bukan application of third Newton law ya kelas. Must understand lah benda tu. So if a car is accelerating forward, it is because its tire are pushing backward and the road is on the road and the road is pushing forward on the tires. Maka bergeraklah dia. Kan? Okay. Rocket move forward as a result of the push exerted on it by the exhaust gases which the rocket has pushed out. So dia akan bergeraklah ke arah yang dia nak. In all cases, when two bodies interact, the action and reaction forces act on different bodies. Okay. Maksudnya force yang sama tapi kita refer pada benda yang lain tu. Okay, so kita dah masuk application of Newton's law. So kita akan apply yang ni dan yang ni sebenarnya kita akan sambung esok lah.